Okay, this is 9.2, talking about pyramids. All right, so let's identify the different parts of the pyramid, and then we're going to name the pyramid. So when we talk about a base, we're talking about this pentagon down here, LMNPQ. So this pentagon down here, so that would be our base. Our altitude is our height. So that's going to go all the way from this top vertice all the way down to the middle of our base. So that's going to be H. Our base edges are the same, LM, MN, NP, PQ, and QL. We also have the vertex of the pyramid. So that's this guy way up here. This is the vertex where all the lateral faces meet. Vertices including that one. So we have K, L, M, N, P, and Q. And then the lateral edges are these things right here, these segments that connect the vertice of the pyramid, the vertex of the pyramid, down to the base. So when we name this, we name it by the base. And so this is a pentagon, so we're going to call it a pentagonal pyramid. Okay, take a moment to read this and see make sure you understand what a regular pyramid is. So pause the video if you need to. Okay, slant height. This is something that we haven't talked about before. The slant height of a regular pyramid is going to come from the altitude from the vertex to the base of the lateral face. So we can think about it like this guy over here. We have our altitude to the middle of our base. It goes across, and then we're forming this triangle here. So our slant height goes from the vertex of the pyramid, down the face to the base edge here. So the length A of the apothem of the base, so that's this guy right here, the apothem, remember, is the height of the base, goes from the center out to, that's perpendicular to the base. The altitude H, so that's how tall it is here, and then the slant height L. So we can use the Pythagorean theorem here to solve for either the height, the apothem, or the slant height in any regular pyramid. So make sure that you understand the difference between the height and the slant height, and we use the cursive letter L to stand for that slant height. Okay, surface area of a pyramid. We've kind of already talked about this, about looking at nets. We can cut it apart, draw it flat. We can see all the figures. So we see that we have all of these triangles here. And so we're going to consider end side of the base. And we're not going to take time right now to derive anything. Okay, here's the formula that's important for the lateral area of a regular pyramid. That's really important. The lateral area of a regular pyramid with a slant height of length L and a perimeter P. So when we have a regular pyramid, we're going to use 1/2 LP. So here we're told that the base has 8 centimeters as the edge, and the lateral edges measure 10 centimeters. So ultimately what we want to do is we want to draw in the slant height from the vertex down here. This is what we're looking for our L. So we can use this triangle right here that we've just made. So if I redraw that triangle, I find out that this is L, this is my 10 for that height there, and then I'm cutting this in half, so this becomes 4. So now we do the Pythagorean theorem. So take a moment and see if you can solve that. All right, so you should get 2√21 as your slant height. We know that the perimeter, we have a pentagonal pyramid, so I have 5 sides, so perimeter is 5 times 8. That's 40. See if you can put that together to figure out what your lateral area is. So you should see that we get the lateral area to be 40√21 centimeters squared. All right, total area or surface area of a pyramid. We use the lateral area and the base. So this is our formula for that surface area. So if we're doing this problem, see if you can take what we just did and put it together with the base to find our total surface area. Okay, why don't you check to see if you got this right? So here's my slant height that I drew in on the face. Here's the triangle that I pulled out. I was able to get 4 root 2 as my slant height. I found my perimeter by multiplying 4 sides by 4 for each, and then my base is side times side, so that's 16. So when I plug all this in up to my formula that's up here, I get that my surface area is half of my slant height times my perimeter plus my base, and I end up with 32 root 2 plus 16, or 61.255 feet squared as my total surface area. All right, so this is the difference between a regular square pyramid and just a square pyramid. This one, we know a regular square pyramid, all the sides and edges are congruent to each other, whereas with just a square pyramid, we have no idea. You're going to have to calculate each individual face to find that lateral area there. All right, volume. Volume uses this formula right here. If I were to take a cube and cut it into pyramids, I would end up with 3 of them because I could actually put this whole box over here. I could fit another one right here and then another one over here. So that's why we use 1/3 the area of the base times the height. If we just did base times height, we would get the cube, but we have to do 1/3 because we're only finding 1/3 of it. So to do this one, what I want to do is I want to first find the area of my base. And I know that the area of my base is 6 times 6, or 36. And I know that my height here is 4, so when I plug in for my volume, I get 1/3 the area of my base, which is 36, times my height of 4. So I get here that this reduces down to 12. 12 times 4 is 48, so I have 48 inches cubed as my volume. Okay, find the volume of a regular hexagonal prism. So these words are important. Regular tells me that all sides and faces are congruent. Hexagonal tells me that that's what my base is that it's a hexagon. And pyramid tells me that it's going to be, for volume, 1/3. So I want to find the volume. So we know that the volume of a pyramid is 1/3 area of the base times the height. So if I have base edges of length 4 and an altitude of 12, how can I do this? Well, first we have to find the area of my base. Luckily, we know how to do that because this is a hexagon and it's a regular, so that's where that word comes important. So my base is going to be 1/2 the apothem times the perimeter. And lucky for us, they've broken it down. They've told us what our apothem is. They've told us that it's 2 root 3. And then my perimeter, I know that I have 6 sides, and they're all 4 inches, so that's 24. So when I plug in for my area of the base, I get 1/2 of my apothem, which is 2 root 3, because that comes from right here. And then I'm multiplying that by my perimeter of 24. Those will actually cancel out, and I'm left with 24 root 3, and that's for my base. Now when I find the volume, I just have to plug it in. So I see that volume is equal to 1/3 of the area of my base, so 24 root 3. And then that gets multiplied by my height, which is 12, and that came from right there. I know that these cancel out to give me 8, so I get 8 root 3 times 12, or 96 root 3. Look at my units. I'm inches cubed, and you could plug that into your calculator if you had to approximate. Okay, why don't you see if you can take some time to figure out what the amount of roofing is necessary. Now think about it. When we're roofing something here, do we look for the volume or the surface area or the lateral area? So think about that for a minute and then come back and we'll set it up. Okay, so you should have figured out that we want the lateral area. When we shingle a roof, I don't care about what's happening down here on the floor. I don't care. That's attached to the house. I just care about each of these faces and how many shingles I can put on the face. So I know that my lateral area, since it's regular, is 4 times the face area. And I know that if the face is 1/2 the base times the height of that triangle. But for us, instead of using the letter H, we're going to use the letter L because this is looking at just this face. So we're actually looking at the slant height of the pyramid. So I shorten that to 1/2 base times the slant height. Why don't you take a minute and see if you can plug in everything and figure out what the area is of the pyramid. So if you can tell, I already found the slant height. I knew it was a Pythagorean triple, 5, 12, and 13. You could have also done the Pythagorean theorem. So once I plugged in, I had 1/2 my base of 10 and my slant height of 12. So I got half of 120 is 60. So one of my faces of my regular square pyramid is 60 feet squared. But I know that my lateral area is to go all the way around, so I have 4, so that gives me 240. So 240 square feet of the roof needs new shingles.